All right, welcome everybody. Um, my name is Chris Fleck. We're going to get going here in a second talking about automated testing and quality assurance and what we've been doing at Dematic to kind of bring that to the next level. We've been leveraging a lot of things that Configure has been using and has given us to play with, which is available to everybody. This is the Snapper performance trackers, ranking tools, all of that. We're going to show a couple of those today. But with our extension, ours is just a little bit different. We have some functionality that is kind of diverges quite a lot from what the typical seating industries and other industries have going right now. So we needed to create some testing of our own in order to make some of that happen, so that we could actually get this automated testing done. So we're going to talk through some of that today. First off, a little bit about me. I've been at Dematic for about 16 years. I started off as a mechanical engineer, then went into software development. There's a big turn. And then finally, I'm leading our DevOps team in Grand Rapids. Has anybody else have worked with DevOps before here? Yes, no, maybe? One? Okay. And a half? Okay. Okay. On a more personal note, have 2 kids, a beautiful wife, love her to death. I'm big into photography on the side. It kind of flows with what you guys are doing with the whole seating industry and CET as a whole from a conceptualization aspect. I also love singing. There's a good picture of the choir on Sunday morning, bass section. So, but Dematic does things a little bit different. We tend to be on a more grandiose scale as compared to what the typical industries that have been using CET. In a normal situation, my understanding from talking with people, you're dealing with like 6,000 to 30,000 or 300,000 square foot areas. We're dealing with million square foot facilities, and conveyor that can be anywhere from about 14, 16 miles of conveyor running through this facility and trying to organize all of that with the rack. And these are just a couple of the concepts that have come out using CET. We've only been using this 18 months, and we're starting to finally get a handle on getting some of these things out the door and into customers' hands and say, hey, here's a solution for you. So we've been doing a lot with the growth over the past 18 months, and we're still growing. By no means are we there yet. We're experiencing problems, just like anyone else growing is also going to have. But we're also working extremely tight with Configure right now, and I can't thank you guys enough for bearing with us during our little construction period, because it's been a whirlwind. Most development teams right now, I've been hearing are 2, 4, 6, maybe 8 developers on a team. We're dealing with, if you're talking pure developers right now, we're up to probably 25, 30 developers on our team. And we have 50 people working on this thing as a whole. So we got people working in catalogs, we have people doing the actual coding behind things. So it's a growth process. And because of how many fingers are in the pot, there's a huge possibility for error. And we really want to try and avoid that. So one way to do that is through automated testing. It was natural to bring it into the whole DevOps scenario. Originally we were trying to do it just as a group, as a whole, but it became more pronounced as we went along in our releases, our major releases. The team that I'm responsible for right now, we do simply the building. So we do all the code merges from the dev branch into the RC branches, and we go ahead and do testing, we deploy. But then we also, on top of that, we're building up our automated testing cases right now. We still have a long ways to go. We've laid our foundation. There's still a few foundational items that we need to get in, but it's a learning curve. As you start experiencing and getting deeper into the code, you start realizing, hey, I need to test this also. Maybe it'd be good to test this out. As new things come up, as features change, we need to make sure the code changes along with it for that testing. So why would one want to do automated testing? Well, first off, it allows for a very fast, very consistent test. I want to do the same thing to the snapper every single time. And to give you an idea of just how much of an improvement you're looking at, okay, at least from our extension, we have a particular model that we would test, and it would take about an hour and a half to actually run through all the testing, and that's inserting, copying, moving, stretching, open, close, do all the quick property changes, you know, check bill of material, check, you know, the quote, all of that. It would take us about an hour and a half to make sure that everything was clean, everything was valid as we went through. Now doing automated testing, we can do all of that and a little bit more in about 60 seconds. I'd call that a win. Now, we are leveraging a lot of things that Configure already has in place, you know, which is awesome, because we don't have to recreate the wheel. We can actually use the wheel to help drive us where we need to be. And so the fast, consistent tests, it's fully customizable to what you need. Like I said, our extension is a little bit different. There's features in there that are completely different than what you guys have experienced. But each company may have those type of scenarios. So why not build a test case against it? Why not take something and that you know the users do all the time, and it's a function maybe you guys have created, maybe a new method, maybe a new way of doing something, and build an automated test against that to ensure that it works build after build. It also gives you a way to provide a quick validation of the software stability. So ultimately, when you're done, you can actually go into the builder and have test cases set up for these things. Go ahead and just click the entire build, and it'll go through each automated test case. And then when you're done, it'll give you, you know, green for hey, it worked, or red, hey, it didn't build. Okay. So for those of you who do building of the extensions, that's built right into that. As long as you build the test cases up for it and program it properly, you can run it through that process. It'll give you a go, no go on each test that you perform. You can also do in-depth analysis of all possible variants. One of the things that we're doing is in the quick properties. We want to do multiple iterations of a test. So we'll bring a snapper in. We'll run a bill of material, for instance. Make sure there's no invalid part numbers in there. Then we'll go through another cycle, but we'll take that same snapper and we'll change a quick property. Do it again. Okay, change another quick property, do it again, stretch it, do it again, stretch the width, do it again, change the elevation, do it again. And it's randomly picking these things. And we can set it up for 1,000 iterations and just let it run. And it'll generate a report telling us, hey, I've run this 1,000 times, it failed 3 instances, and out of those 3 instances, here's your configuration that you need. So I'll kind of show you what we're doing in that. But it also allows a higher iteration for every RC cycle. So repeatability. You know, right now we have one and a half, maybe 2 people on a typical build that are dedicated to RC testing. And if you do all manual testing, that's a long time. If you can automate even a portion of that, that's great. Now, in my mind, you're never going to be able to automate everything, because some of it, I know Magnus talked to that yesterday, some of it's just how does it feel? You know, I mean, it may work great, it may function great, numbers may come back saying, hey, I worked well, but when the users get to it, if they're moving things around and it's kind of jittery, things aren't working right, things are, you know, the flow isn't there, it's going to be very disruptive. So some of that has to be human testing, but if you can spend more time human testing and put the more fundamental things in automated testing, I think that's huge. So let's show you what's going on right now, show you a couple of things that are out there. I'm actually running 8.5 at the moment, so for those of you, hopefully everyone's at least on 8.5. Yep, I saw a big thank you. Yes! Those of you who are running 8.5, I highly recommend getting used to some of the new features in here, because these are going to be awesome, okay? One of the things that you have, I'm just going to drag a snowman in here. One of the things in the debug menu is everyone should be familiar with the Snapper Performance Tracker, at least one way or another. The Snapper Performance Tracker gives me an indicator of how does this thing sit. And it might be a little difficult to see here, but what are my general performance issues with this? You know, the amount of resources as far as 2D and 3D lines and triangles that it's actually taking to build this thing. What's the performance look like for constructors and Getting average parts and getting the 2D and 3D builds. How long is it taking to do some of that? The new stuff down at the bottom here, the responsiveness, this is something that just got added, and they're still doing some additional work on it. So definitely pay attention to stuff coming out on that. But it's going to be things like clicking. What do you do? How long does it take to click for moving, rotating, copying, things like that. Those are all important aspects that need to be accounted for when you're developing new snappers. So you can actually run this on any snapper. I can bring the teapot in, everybody's favorite. And as long as I have it on here, I can see. I'll reset the averages. Don't know what just happened there. I think I put in way too many. Make sure I didn't crash here. Nope, still doing something. Anyways, while we're waiting here, what you can do is utilize this, and it's going to be on each snapper that you click on. Okay, so it's going to be on the active snapper that's sitting there. Apparently, I updated way too many times. So another component to this, maybe. Is what we call the dramatic pause. The other thing that you can do is actually do a snapper ranking tool. Okay, and I'm going to show you a nice feature that we're actually utilizing when we're testing our extensions right now. I'm going to go into our controls. And these are simply electric devices that get added onto our conveyor. Inside of the ranking tool, the snapper ranking tool, I have the ability down here to actually rank the toolbox card. And what this is going to do is it's going to take the toolbox that you currently have active and insert every possible snapper in there. Okay, so I'm going to go ahead and just run this. And it is going to insert one of everything into the drawing and then run an evaluation on it. So if I just drag this out of the way, you can see there's all the devices just got added in. Okay, it's a very nice utility. And from that, I get this beautiful list. Of different things that I can look at performances on. I can do show all tracked info, and that's going to give me a wealth of information. Okay, it's going to show me my 2D lines and triangle lines. I can just show memory aspect. I can show speed, responsiveness. I can do zoom 2D and 3D. I can rank just the selected one. I can rank all of them, which right now I'm ranking all of them. I can go into my drawing, select maybe 3, and just run the performance track on those 3. Okay, this is stuff available to you today. Okay, so if you're not using it, definitely start using it. It'll give you a nice insight as to where problems might reside. Okay. Now beyond that, what we have done from at Dematic is we've created another extension or another component to lay on top of that. So we're utilizing all that information that we're getting from those trackers. We're just making the calls and grabbing the information from those methods. But then we need to do specific changes in ours because we're running our bill of materials different than most people. We're running our quotes different than most people. There's different attributes in send calls and drawing saves and things like that are a little bit different than the average company. So what we would do, I'm just going to bring a model in here, ever so gently. For those of you who have not seen conveyor before, there's conveyor. It's exciting, I know. Not sure why it's taking so long. Oh, I know why it's taking longer. This isn't the background correct. Yeah, it did, didn't it? We'll summon it. Maybe we won't do that one. Let's choose a different one. I think I gotta start over. Many apologies. We are working in a live dev environment, so please stay tuned. But what we have done, though, is we have created what we identify as the Dematic test jig. Okay, and I know Johan started creating the box, so thank you for that. That gave us a foundation. So, but we were using it for a couple just quick tests to do it, and since it already existed there, it was a perfect staging area to add all of these additional tests that we wanted to do. Now, what we did is we started breaking things out, and originally we were trying to do everything possible in one run, and we realized as we've gone on, it's really not the best way to do it. Maybe we want to really focus on certain areas. Maybe we'll do a single run in this scenario, and we'll do multi-iteration runs in this scenario. Oh, wait a minute, we have CM3D files we should probably be checking. Okay, well, there's another one. Full drawing checks. Okay, let's run through those. So what we've done is we have this, what we call a test jig. Okay, the test jig allows me to come in here and I can check general speeds of any snapper in the drawing. So if I'm going to try it again. We're going to bring in this model, see what happens. I will say performance is on our to-do list for sure. Okay, so I have just a piece of conveyor in here, and I can run 5 iterations of this to see what the speed is going to be like. And it's going to take a look at every snapper that's on that, and it will give us a bunch of odd information. We got to look at that one. Not sure what happened to that one. Yeah, probably. Maybe I should fire up 8.0. I think I'm going to fire up 8.0. I'm sorry. So let's do. Oh, natural. I got to connect to Wi-Fi.
You should be able to open up Emacs.
You should just click on it.
Just open up Emacs.
Just do the. Let's do the 5, right?
Emacs doesn't want to open on that one. Huh. Can you just fire it off from here?
Yep.
See what happens. Okay. But we have. And we're gonna try one while this is going, because I tested this last night and it was working great. We also have a CM3D performance test. Okay, and this is, we have a lot of CM3D files that are coming in. Some from vendors, some from just our R&D department that we need to incorporate into Maestro. So what we're doing is we're searching for all of the CM3D files that we have in our extension, and I can go through and I can just pick and choose. I can pick a cluster of them. So if I do this and I can do a check all, and I'll go ahead and that's going to give me resources on that guy too. So let me do this. So I'm going to go ahead and run these, and it's going to give me a full list of the amount of time it took, the cost, the budget. So how many budgeted lines do I have? How many low, medium, high triangles am I allotted for these items? And this is going to give me a very nice look into, have things been optimized yet or not? And you can see the amount of red on this side tells me no, it has not. So this would be a very good opportunity to increase performance. Okay, I get in and I get in that 2D aspect. And maybe I can par those lines down to 250. And I think, and correct me if I'm wrong, Gustav, you guys were talking about trying to make an algorithm to look at the area versus just a hard set 250. So that one's up and coming. So there's, that's going to be another thing. Right now it's just hard set 250 for 2D lines. But they're going to go ahead and expand it to whatever the area coverage is. So if you have a larger work area, then it'll make that accommodation. If you have a very small profile, like a plant or something like that, it's going to really reduce the amount. So other things to look at. All right. The other piece, the more critical one for us, is the bill of material tests. So I can come in here and I can say I want to run any of these models, and I'll just run a little bit leery running the last one. We're going to try it one time again. So I'm going to go ahead and run a test on this. And this is going to insert, and it's going to do all of the testing that I wanted to do on this. It's going to insert a new snapper, insert a cache snapper. It's going to copy, it's going to move, it's going to rotate, it's going to stretch all possible stretch points. It's going to give me a performance. You can see the dialog that popped up here. It gives me a performance on, you know, the number of 2D lines and 3D triangles that are being used to generate this thing. A simple quick property test. Now I say simple because we're not going through every possible iteration of the quick properties. We're going through each quick property and changing it one time to make sure that it's at least sound. The other bill of material in quote testing is what we're going to be doing the multi-iteration on, changing every possible value. But like I said, we insert a cache snapper, move it, copy it, rotate it. We stretch every possible connector that is stretchable. And this does go down to a bed level. We have a scenario where you may have a unit that consists of multiple beds. And we can now take that unit, we'll test the unit as a whole, but then we'll go into the unit, into bed space, and begin working each individual bed to make sure those beds work properly. We then go into, we give a total testing time, and then we have a bill of material testing. In this case, I have 3 different snappers that I tested. They all tested out fine. Okay? If something went wrong, then what I'll see is something like this, where it's going to give me the quick properties. Okay, and it's going to say, hey, you know, this particular bill of material failed. This is how you set it up to match that bill of material, so you know how to reproduce that issue. We're testing undo. Undo's been a huge thing for us lately, as people keep forgetting to take care of undos. And so this is going to give us the ability to test all the undos properly. And then we also have what we're calling the golden model drawings. Okay, so for each one of these models, we have a drawing set up with a ton of different variations of it, different lengths, different widths, different quick properties. And we're simply opening those drawings, testing to make sure that things are working. Okay, it's a simple load, save, load. But it's going to enable us to make sure that nothing has failed in that regard. Now, bill of material testing, I'm not going to run through this one too quick, but because we're getting a little bit low on time, but the integration down here allows me to change the number of iterations that I run the bill of material test for, or the quote test for. So I can set it up for 5, I can do 10, I can do 1,000 if I want to, and it'll just sit there and crank away until it's done, and it'll give you a final list. In fact, I'll run them on one of them here. So we'll do an iteration of, say, 10. So this is going to go ahead and do a change every single time, and we do need to adjust our progress bar at the top, because yeah, we're not done yet, but there we go. So you can see here that if it didn't have a failure, it's going to show us, hey, it passed, great. If it passed, I don't care about what the configuration was, because it worked. But if it does fail, it's going to list out all of those quick properties and tell me, okay, this is how you need to reproduce it. The other final thing that we're doing is a comparison test, and this one's a little more in depth. What we're doing is we're taking I'm just going to throw some things in here a second. So I'm going to take that, I'll plug one of those in, and let's run one of these. So we've got a nice little setup here, things going around, pretty simple. I can take this drawing and I'm going to create a baseline template for it, a baseline Excel file. And so I'm going to go ahead and run this export on this test. And I'm going to call this, I'm going to save it to my desktop, and we'll save it as export test. And overwrite it, yes please. Okay, now what I can do is, down the road, I can use that Excel file as a comparison. Okay, so if for some reason I open up this drawing and something has moved, I need to know what moved. Okay, now I'm not sure how many people have had issues in the past with this. I know we've had issues on our side because of how we're dealing with some of our snappers, but we've had drives move, we've had units completely disappear. And when you're talking, you have 1,000 units that you're dealing with in a drawing, going one by one to make sure every one of them's there is really tedious. So, and sometimes it's a component of the snapper, of the unit. So like my drive might have moved a little bit. So what we did is we now have the capability of saying, okay, I am going to take this guy and I'm just going to, let's see here, I'm going to go to single select. I'm going to just drag him over here, and I think I moved everything already, so everything's probably going to pop up. But I'll rerun this comparison. I'll select the same table that I just exported, run and open, and it's now going to tell me everything that's changed. So this unit, the position changed from this to this. Same thing here. Part number is now missing. Position change, position change, position change. So I did move everything at one time, but this is going to enable us to take an entire drawing and review it. Assuming we still have that base export, and we need to make sure that we create those base exports against our regression test drawings that we have. Right now we're sitting probably 16 full drawings that we have. We're trying to get more from the end users. So if you have good ones in particular, let us know, and then we'll load those up. But we want a nice base to start from, to say if we have problems, let's find them. Let's use these projects that have been done in the past, compare against them, and make sure everything is still sound, because we get into drawings over and over and over again throughout the years. We'll go into facilities and do retrofit work. So we're adding ship lanes, we're adding a sorter, we're completely changing how a merge is done. So there's all these things that are taking place in these facilities that require us to go in and out of these drawings year after year. So as these things come out, we want to make sure we're not breaking them. So this is just kind of a sampling of what we've been doing at Dematic. I highly encourage everybody, if you are not doing something like this, consider it. Bare minimum, utilize the tools that Configure has. I mean, they got some great tools out there with the performance trackers, with the ranking tools. I mean, there's a lot of new things that are coming out, and a lot of cool things coming out that's going to help you guys make sure your extensions are as solid as possible. So, any questions? All right. Thank you very much.